Today's lesson we will cover in section 8.7, solving quadratic systems. We will learn to solve quadratic systems of equations and inequalities. What we mean by quadratics, we're going to be seeing systems of equations that involve parabolas, hyperbolas, circles, and even linear equations and where they are intersecting. Always keep in mind that when we are solving a system equation, we are finding where do the equations, where do their representations intersect. Okay, so we're going to see equations that have lines and different conic sections. So the question is, how many times can a line and a conic section intersect? Take a conic section of a circle. Okay, you can have a line that doesn't intersect it. You can have a tangent line that intersects it at one point, or you can have a secant line that intersects it at two. Okay, there are no other ways that a line and a conic section can intersect. Take a parabola. You can have no intersection. You can have one intersection. You can have two intersections. Okay, take an ellipse, very much like a circle. We can have 0, 1, or 2 intersections. Take a hyperbola. Okay, is a hyperbola any different? Can we have more than 2? Okay, we can have none. Okay, you can have 1 where it's hitting at a vertex. We can have 2 in many different ways. Okay, but there's no way to have it cross at 3 different locations. Okay, how many times can two conic sections intersect? That's a different story. Now we're talking about circles with ellipses or parabolas. Okay, when two conic sections could not intersect at all, you could have 0 intersection. Okay, we could have a circle with a parabola where the vertex is hitting at one point, so we could have 1 intersection. We could have an ellipse with a parabola, and it could create the scenario of 3 intersections. So we can have, right now, we can have 0, 1. I put 3. We could have 2. I forgot 2. Okay, let's figure out a way we could have 2. How about a circle with a parabola looking like this? There's a 2 intersection. Okay, but we can also have 4 intersections. Okay, the array. We can have a hyperbola and a circle around it with 4 intersections. So with two conic sections, we can have 0, 1, 2, 3, or 4 intersections. You really won't know going into the system what you'll expect, but you know the maximum that you can have. So let's see some examples now. We're going to find the solution, okay, of this system. Notice we should be able to identify that we are looking at a hyperbola and a linear equation. Okay? The conic section in a linear equation, we can have 0, 1, or 2 solutions. That's one of the first things that we need to think about. Okay, this is a linear with a conic section. How many solutions are possible? We just said 0, 1, or 2. Okay. Can we use the elimination method here? Most of you would probably choose the elimination method to solve a system of equation. My question to you is, can we use the elimination method? Some of you may be saying, yes, I can use the elimination because I can square this. But you're thinking, well, let's just square those numbers. But again, we know a binomial cannot be squared like that. Okay, if you say, well, let's square both sides, you need to FOIL this, and you would create an xy term that would not eliminate. So can we use the elimination when we have a linear equation and a conic section? No, we cannot. We cannot use the elimination method when we have a linear equation with a conic section. So we have no choice. We have to use substitution. Okay. It says, which equation would you want to solve for, x or y? I would hope all of you would say the linear equation. Because if I solve the linear equation, I just solve for x and y. If I solve the conic section, I have to solve for x squared or y squared. The linear equation would very quickly solve for x by adding the 3y to both sides and getting x equals 3y. So that is the method we're going to use. We're going to solve the linear equation for x, and then we are going to substitute that value in place of x into the conic section. Now that conic section is all in terms of y. It's in terms of y squared. So we have 9y squared minus y squared equals 8. Simplify, we have 8y squared equal to 8. Simplify, we got y squared equal to 1. And what do we need to do when we square both sides to solve? We need to write that as plus or minus 1. You have two possible values of y. So now you need to find the x value that goes with each y value. Okay. To the left and the right here, you see what's going on. And this is where y equals 1. Okay, it's into the linear equation. We put the 1 in for y, solve for x, we get 3. So 3, 1 is one intersection point. This is where y equals negative 1. Again, same equation, linear equation. Solve it for x, we get negative 3. So negative 3 pairs with negative 1, that is a second intersection point. Remember, for a linear equation and a conic section, you can only have up to 2 solutions. See another example. Okay. Hopefully you're recognizing that this is two conic sections, a hyperbola, and an ellipse. Okay, but as you remember, how many solutions are possible when two conic sections are used? 0, 1, 2, 3, or 4. Now that we have two conic sections, look at the way it's lined up. Can we use the elimination method? I'm hoping you are saying yes. Okay, we can use the elimination. We can eliminate an entire x squared or y squared. And again, that is a helpful thing. Okay, so let's see this one in process. We are going to use the elimination method. Okay. Looking to the left here, I'm taking the top equation, the hyperbola, and multiplying it by negative 4 to get the x squared terms to be the same value. So we got the negative 4x squared now, plus 16y squared, now equal to 36, and now we can add going down to eliminate the x squareds, and we will be able to solve for y squared. Okay, so we have 25y squared is now equal to 0, y squared equals 0, means y is 0. There is no plus or minus 0, so just y is 0. Okay, so now we take that value of 0 and we input it. This is being inputted back to the first equation. It can be inputted into either equation, and we solve for x squared. Okay, we get x squared equals 9, and we get plus or minus 3 there. That means both positive and negative 3 both pair with 0. Okay, that means there are two possible answers, 3, 0, and negative 3, 0, which can be rewritten as plus or minus 3, 0. Take a moment to try this equation. Pause the video, give it a try. Okay, let's go over this together. There's just two conic sections. We have an ellipse and a hyperbola again. So now we want to go ahead and try to use the elimination method. Okay, for the elimination method, I am going to choose to multiply the top equation by negative 2 and the bottom equation by 3. That's the way we're going to be able to eliminate the x's. So I have negative 6x squared, excuse me, minus 4y squared equal negative 42. And then I have positive 6x squared minus 15y squared equal to negative 72. Okay, add going down, and what I have here is negative 19y squared equal to negative 114. When I divide both sides by negative 19, I get y squared equals to 6. Don't expect everything to be perfect squares. When we square root that now, y is equal to plus or minus square root of 6. So now when I want to solve for x, I have to solve for both cases. Okay, I have to solve for when y is equal to positive square root of 6 and when y is equal to negative square root of 6. I'm going to take the first equation to do this. Okay, I have my 3x squared plus 2 square root of 6 squared equals 21. That's 3x squared. That'll just be 2 times 6, which is 12, and it equals 21. 3x squared now is equal to 9. X squared is equal to 3. So when I square root that, I get plus or minus square root of 3. Okay. When I take care of the other case, I got 3x squared plus 2 times negative square root of 6 squared equals 21. Hopefully you realize that when the negative number is squared, it's the exact same as the positive. So the equation ends up being exactly the same. So we already know our answer is going to be plus or minus square root of 3. So what that means is both positive and negative square root of 3 work with both positive, negative, square root of 6. Technically, that is 4 solutions, square root of 3, square root of 6, square root of 3, negative square root of 6, negative square root of 3, square root of 6, and negative square root of 3, negative square root of 6. But we can write that as plus or minus square root of 3, plus or minus square root of 6. I'd like you to come into class with this one done, and we will take a look at this in class. The next thing we will be doing is we will be solving quadratic systems of inequalities. Okay? To solve these, we have to graph the solution. Okay? So we have to be able to graph the inequality parabola and the inequality circle here and find where the solutions are overlapping. So our first step is to graph the parabola. It's almost in standard form. Okay, or vertex form. We just add the minus 0 there, and it's in vertex form. We have a vertex at 0, 1. It is opening up. We can find another point, and there's our parabola. We want to shade it, so we test 0, 0. Put in 0, 0. Okay, into the function. Put in 0 for y, and you get 0 is greater than 1, which is not true. 0, 0 is outside, so we shade inside the parabola. Now we need to shade the circle. This is circle, it's already in standard form. Circle with center of 0, 0 with a radius of 3. So you see the circle being drawn. Both of them are solid boundaries. We need to shade the circle. So we test 0, 0. 0, 0 is inside the circle. Put in 0, 0, and again, 0 is less than negative 9. That is true. So we see we're shading inside the circle. For our final solution now, where's the shading overlapping? The shading is overlapping right there. Okay, where the parabola and the circle's shading meet. That is our solution to this system of inequalities. Take a moment to work on this, please. We will look at this in class tomorrow.